Hello students, welcome back. Let us resume our discussion in section 2 of this notebook. We talked about graph of an equation with two variables, and here's an example, but I can consider other kind of examples too. And we discussed how to check a given point is on a curve or not. Basically, what we can do is to plug in those numbers and see the equation is true. Yes versus no. In other words, yes, the point is on the curve, or no, the point is not on the curve. Now let's go to the next topic, intercepts. Not just checking, this time we want to solve an equation. Find all x-intercepts, find all y-intercepts. Here's a picture. And what do you mean by an x-intercept, or rather x-intercepts in plural? The x-coordinate axis cut through this curve twice. Right here, around x equal to -1, it appears, and right here, when x is equal to +1, it appears. And are there going to be more? It's hard to tell. This curve may cross later on, or it may be just asymptotic. Same thing goes here. Just by looking at this graph, it's a little bit difficult to tell. But then again, even if it were easier to tell, still you have to do this algebraically to make absolutely certain that you have all the x-intercepts there is. So how do you do that? Let's come back to this again. These 2 points are right on the x-axis, which means the vertical distance is 0 from the x-axis, never goes up or down. So y-coordinate is 0. So that's the idea. To find the x-intercept, plugging y is equal to 0, and you're looking for the x value from there. Make sense? Let's go back to the picture again. I'm looking for this x value and that's x value. Both of those points are right on the x coordinate axis, so no vertical movement from the coordinate axis. So y coordinate is 0. So y coordinate is 0 into this, and then let's look for x value. I can open up the cell, but let me slow down a little bit. And then let's do it in a little bit hard way. Plugging in x equals to 0, y equals to 0, and then looking for the x values. So what do we have here? Looks like this one's 0, and that 2 is 0, and I only have x to the 4th power. So x to the 4th power is equal to, okay, how about this one? That's 0. And then we have -x² plus 2. So it looks like we have this quadratic equation to solve. Don't panic. It may be quadratic, but we have only 3 terms. So this is actually a trinomial. You can use the solution method for quadratic equation for this. X to the 4th power plus x² minus 2 is equal to 0. And let's do it by factoring this quadratic trinomial. It's quadratic, but you can reduce it into quadratic. How do you do it? Well, factors of -2 adding up to this middle coefficient. What times what? +2 minus 1, right? So +2 times -1 is -2, all right? And if you add them up, +2 minus 1 is +1, so it looks good. But something is not right here. If you break this up, you're going to get quadratic, x to the 2nd power. But this one is quadratic. How do you adjust it? This should be x² plus 2 and x² minus 1. Does it make sense? If you have GCF, then I can take x out, and then you're going to have some reduced quadratic trinomial to work out. But there is no GCF here. Instead, we have to look at this one as x squared and then x squared squared. So this is quadratic of x squared. So factor it with respect to x squared, and there you go. So previously we had just x and then x. If you disregard this fourth power and second power, but this is fourth power and second power, so we have to factor it with respect to x squared. So putting those x squared in there, we have the factorization. And then we can go further. X squared plus 2, that's irreducible. You cannot reduce it any further. X squared plus positive something, it doesn't have any prime, it doesn't have any non-trivial factor. It's irreducible, it's prime. X squared minus 1 or x squared minus 1 squared, in other words, that one can be factored. X squared plus 2 is irreducible, but this one, it can be factored like this. What factorization formula did I just use? A squared minus b squared is a plus b, a minus b. I just used it. Here, this one is 1 squared. 1 squared is equal to 1. So yeah, you can do it like this. And then let's continue. Setting this one equal to 0, you don't get anything. X squared plus 2 is equal to 0. That never happens because x squared plus 2 is always positive. X plus 1, set it equal to 0, then what do you get? We get x equals to negative 1. And then x minus 1 is equal to 0. I'm going to get x equals to 1. So we have these two coordinate for x. So we have x-intercepts, x equal to negative 1, and x equal to positive 1. Let's check. I don't need this anymore, actually. It's all here. And then here's a visualization. So this one corresponds to the green point, and this one corresponds to the red point. And red point came from this red factor, and green one came from this green factor. Not the other way around. You have the sign change. All good? You think you can do this? Well, I have an example problem down here, so you'll be able to do this shortly. But let's finish this problem. This time, let's find all y-intercept. So, okay, y-intercept, I'm looking for this point and that point. This point looks like y equals to 1. This is y equals to 2, so y equals to 1. This one a little bit hard to tell, so it looks like we may have a fraction or something. In any case, from the y-axis, I have no horizontal movement. So x-coordinate is 0. So basically, I'm plugging x equal to 0 to the given equation and solving for y. So does it make sense? Plug in x equal to 0. So if I plug in x equal to 0 here, x equal to 0 here, and x equal to 0 here, what do you get? Please stop the playback and then write it on your own. Do you get something you can handle? You should. You're supposed to get something like this. Plug in x equal to 0 to these, and then all those zeros drop out, and we have quadratic equation of y like this, and then here's the standard form. Now, can you factor it? Insert table. Okay, so first number and then the last number, and multiply those two. 5 times negative 2 is negative 10. And then factors of negative 10 that add up to negative 3. What times what? 5 times 2 has difference 3, and which one is plus, which one is minus? Looks like that's what you're going to need. Negative 5 times positive 2 is negative 10, and they add up to negative 3. Okay, filling up this puzzle, horizontally, vertically, there should be all multiplication. Looks like I'm going to get 5 times negative 1, and then 1 times positive 2 like this. Please check, horizontally, vertically, everything should be just multiplication. And then cross multiplication, 5, 2 versus 1, negative 1. There you go. Sorry about that. Okay, everything is correct. I mean, this tic-tac-toe is correct. What I had over there early on is wrong, but now corrected. This cross, 5, positive 2, and the other cross, 1, negative 1. So we get this. And setting this one equal to 0, I'm going to get negative 2/5. Setting this one equal to 0, I'm going to get y equals 1. Let's see, do we have a visualization here? Yes, 0, negative 2/5. This corresponds to this green point, and 0, 1. This one corresponds to the red point. And y equals 1 corresponds to this factor, we just highlighted in red. And then y equals negative 2/5 corresponds to this factor, we just highlighted in green. And then we have this visualization. Everything is in place. So how do you find intercept? Looking for x-intercept and plug in y equal to 0, and so for x. Looking for y-intercept, then plug in x equal to 0, and so for y. In any case, you may have to solve some polynomial equation, especially quadratic equation or any version of it. Okay, now that we went through some example problems, can you do these? Find all intercepts for ellipse. Turns out ellipse, and let me see. Oh, I don't want to show you the. I don't want to show you the solution yet. So let me just show you graph, and looks like this. So x-intercepts there, y-intercepts there. Okay. And then next example is called hyperbola. I don't want to show you the answer yet, just a picture. And it looks like this. And I expect x-intercepts there, but no y-intercept. And then this one is gonna be parabola. Again, I don't want to show you the answer just yet, just a picture. And it looks like this. It looks like we have 0, 0 there. Nothing else. By the way, these kind of curves are called conic sections because of this observation. Consider a couple of cones like these, and then cut those with appropriate plane. Cut this parallelly through the side, then we get parabola. Cut it horizontally like this, we have a circle. Tilt it, then we have ellipse. And tilt even further, then we have hyperbola. Doesn't have to be vertical, actually. That's why they are called conic sections. And they're important in various parts of mathematics and applied mathematics. Nowadays, we have technology, so it's less of an issue, but still,